Hello. Today we are going to understand better the angle of elevation and angle of depression through a problem solving. So we are still going to use the tangent ratio to find adjacent or the opposite side. So let's find out through the example. But first of all, just so that you remember, the angle of elevation is the one that goes upward. So it depends where the observer is. You have to draw a horizontal line with the ground, here for example. And if the observer looks up, then the angle that is created between the horizontal line and the line that joins the observer with the object. So this angle here is called the angle of elevation. And in the same way, if the observer looks down, again, you draw the horizontal line and draw the line that joins the observer with the object, and the angle that is created between them two makes the angle of depression, which I'm calling it as a D and here as E. So elevation and depression. So this is the question that we have. It says from the top of a 25-meter cliff, high, it's 25 meters high, the angle of depression of a jet ski at a point is 20 degrees. It says from the top of the cliff. So this is where the observer is, from the top of the cliff. So underline the word from the top of the cliff. When you underline the word from, so the word that comes after the word from shows where the observer is. Remember this one. And the cliff is 25 meters high. The angle of depression, which means the angle is going to go down. Okay, it's going to go down. At a point A is 20 degrees. So there you go. This is the horizontal line, and this is where the boat is. This is where the observer is. Okay, this is where the angle of depression, which means the angle. So you have to join the point where the observer is with the boat with a straight line, and use rulers when you create the picture of the question. So there you go, just like that. Right, so this is the cliff, which is 25 meters high. I'm going to label it as 25 meters high. Okay, there you go. And this is where the observer is. Okay, and the observer looks down. The angle is of depression. Can you see it's right here? The angle is created between the horizontal line and the line that joins the observer and the object, which is the boat. Now, the jet ski moves in a straight line towards the base of the cliff. This is the base of the cliff, so that its angle of depression 5 seconds later at a point B, there you go, the angle of depression is 30 degrees. Can you see? This is a 30 degrees angle. So do you understand the picture of the problem? So this is where the observer is. This is the horizontal line with the sea level or with the ground, okay? And the first angle of depression, which is the angle created between the horizontal line and the line that joins the observer with the object, is 20 degrees, okay? See, the line goes down, and 5 seconds later is 30 degrees. So we need to find the distance AB. So this one here, from here to here. Now, what do we have? What do we have? Let's have a look. Now, can you see the distance AB? It is the difference between of AC. So AC is the whole AC, is all this length. AC, take away BC. All right? Okay, so AC, distance AC, all of this one, AC, it is part of this triangle, ADC, the big one, or ACD. Can you see all this triangle, which is a right-angled triangle? Why is a right-angled triangle? Because this is a height. The problem says it is 25 meter high, so it's a height. And this angle here is 90 degrees angle. Okay, the triangle is a right-angled triangle. Now, angle, you see the little angle here that I have colored in black, I've called it as angle D1. And I've called this angle here as A1. Now, angle D1 is equal to the angle A1 as alternate angle because this horizontal line goes horizontally with both of them are parallel with the ground. This is how we create it, how it's meant to be. So because, can you see the arrowheads as well? They show that these two lines are parallel. So this line here and this line here. And that means the little D1 angle is equal to the A1 angle equal 20 degrees as alternate angles. Why are they all alternate angles? Because they're part of the, can you see, Z shape? And we said if they are within the Z shape, then they are called alternate angles. All right, so we can have a look at the big triangle, the triangle ACD. So we have the angle, we have the opposite side, 25 meters, so we can calculate the adjacent, which is AC. Let's find out. Okay, so tangent A1 here, right, is equal to 25 meters. There you go, it's 25 over AC, over the side AC, and that is the tangent ratio formula. And if we calculate using the calculator, tan 20, there you go, tan 20 is 0.364, I rounded to 3 significant figures, equals 25 over AC. And this is how side AC, so the adjacent here, is equal 68.9 meters, not this one here. So 68.9 meters, it is the AC, side AC. Now, we do exactly the same thing for triangle BDC or BCD. The triangle BCD is again a right angle triangle. We know angle 2 here that I colored in red. There you go. This is the angle of depression is 30 degrees, is equal the angle B2 equal 30 degrees as alternate angles, exactly the same as the next 30 degrees as alternate angles, because this line here and all this line here, line AC, are parallel. And so in triangle BCD, what do we know? We know the angle B2, which is 30 degrees. Okay, 30 degrees. Let me label it as 30 degrees. We know the opposite side, that is 25 meters. So we can find side BC. So we can find this side here. Right, so we apply the formula of tangent ratio. So tan 30 equals, there you go, tan 30 degrees equals 25 over BC, okay, over BC, right? So 30 tan 30 is going to be, it's a 0.577, so we round it, we leave it to 0.3 significant figures, so 0.5577 equals 25 over BC, okay? And then we multiply both sides by BC to get rid of the denominator BC, and that's how you calculate. And then this is BC times this one, all right? This is BC, okay? So BC itself, okay, is going to be 25 divided by 0.577. Okay, let's find out. BC is 25 divided by 0.577, and the answer is going to be 43.3 meters. So BC, okay, equals 43.3, and the measuring unit is meters. We are working with meters of meters. Right, so BC is 43.3 meters. That means we know AC from the previous slide. We now know BC, which is 43.3. And then so we can find the side AB, the distance AB. by taking away. So let's take away 68.9, take away 43.3, and the answer is going to be 25.6 meters. So AB is this one here. AB, I'm going to write it right here. AB equals 25.6 meters, just like that. Okay, so what is important again is to understand angle of elevation and depression. So to draw the picture correctly, and to understand, to label the angles is very important in the picture, and find out if you have any parallel lines and how the right angle triangles are created, because tangent ratio, they only work for right angle triangles. So that's why you need to be clear when you say why the triangle is a right angle triangle. And so yeah, just apply both ratios and take away, and that's how you find the side AB in this case. And you can apply these skills in other problem solving that involves angle of elevation or angle of depression, and find the sides. So thank you very much for watching Mathssteps. Have a lovely day. Bye-bye.